Hello and welcome. This is MUDASSIR AFRAZ from civiltechnologyforyou.com, and in this session I will cover the topic how to prepare bar bending schedule sheet in Excel. So it is very useful sheet, and at the end you will be able to prepare bar bending schedule sheet for any structure. So let's get started, and here I will merge and center the columns. Okay, and we'll give the name bar bending schedule sheet. Okay, bar bending schedule sheet. Okay, and we'll draw the table here like serial number, description. Okay, serial number, then next will be description of item. Okay, then next will be dia bar. For this I will go in insert tab. Here the symbol option is, and I will insert the dia symbol here. Okay, and insert it into this column and then close it. Okay, and dia bar. Then next will be spacing between two steel spacing. Okay, and then next will be number of items. Okay, number of items mean if I am preparing the bar bending schedule of column, so the same columns are more than 2 or 4 or 6, that could be anything. So we will only prepare the bar bending schedule for one column and will multiply this to the whole numbers of columns. Okay, number of item, then number of bars, then total number, then cut length of one bar, cut length of bar, then total length. Okay, here it will be the total length of different bars. And now here I will merge and centers two or more than two columns, 1 2 and 3. Okay, and I will put what, I will merge and center it, and total length in meters for different dia bars. Okay, total length in meters. Okay, for example 8 mm bar, 8 mm, 8 mm, and then 10 mm, then 12 mm. Okay, for this I will do one trick here. I will just right click here, just remove this one, and I will right click here. We'll go in the format cell, and here is one option like custom. Okay, then here I will do the customization. Just here I will put the numbers through shifts. Here I will put the numbers, and I will put here the double quotes. Okay, and under between the double quotes I will put millimeter. Okay, okay, and then we'll close with double quotes and okay. Here when I will put any number, automatically millimeter will come, like okay, 8 mm. So if I will insert any formula here, it will not disturb the formula. For example, here is the value of 2, and I will multiply these two, this multiply by this, so it is giving me the right answer. And for example, if I will not customize this one and I am putting 8 mm like this and then 2, so when I will put the formula here, it will give the hash value. So this is the benefit of this customization. Okay, let's delete this 8 mm, 10 mm, and then 12 mm. Okay, okay, just remove this formula. Okay, and I will format this one, this format to this one to this one. Okay, 8 mm, 10 mm, and 12 mm. Okay, total dia. So again what I will do here is I will merge and center this one. Okay, format printer, this one, this one, this one, this one, this one, this one, likewise. Okay, and what I will select all and just double click, then I will move this one as per my requirement. Okay, Okay, this one bar bending schedule sheet, and we have prepared the table like serial number, description of item, die of bars, spacing, number of items likewise. Okay, then you can put one column here like shapes of bar. Okay, shapes, and what I will do here, merge and center this one also. Okay, then I will make the table here, select all of this and right click and go in format cell. Okay, in format cell there is one option border. I will make border here, and you can set any style from here. I will select this one, outline inside. Okay, then press OK. So table is complete. I will select it in a, and then bold this one. Okay, or I can use the table instead of this, because this is very format cell. Okay, I will select this one and then okay, sorry, we'll go here, format cell. Okay, border this one. Okay, inside. Okay, it will be good here. I'm just setting this one. Okay, this one, outline inside, and okay, now it is good. Okay, we have prepared the table like serial number, description up to shapes. So we will insert some of the data in it, and we will see how this excel sheet will work, and we will insert the formula here, and that formula is very important. So let's see, I have draw one slab here. Okay, and I have give the some of the values like main bars, distribution bars, and we will calculate this steel in this excel sheet. So first of all, you can see that the main bar 12 mm steel at the rate of 200 mm center to center distance. Okay, this is the main bar. Okay, and we are using 12 mm steel here, and the distance between two bars will be 200 mm. Okay, the center, and the space is this one. Okay, we are placing this steel in this direction. So this is the main bar. Now in distribution bar we are using 10 mm steel, and we are using the spacing center to center is 300 mm. So this is distribution bar. Let's see how we can insert the data in the excel sheet. So I will open it again. Okay, number one. Okay, so number one, this is main bar, main bars, main bars. Okay, dia bar, we will insert the dia. I will copy the format from here because I want to insert this format here. Okay, and then after, what I will do here, I have to adjust this one. Okay, like this. Okay, here, and main bars dia bar. What is the dia of main bar? Here I will go and see what is the dia of main bar. It is 12 mm. So I will put the number here, and automatically mm will come. Okay, 12 mm. And what is the spacing between two bars? 200 mm center to center distance is here. So 200 mm center to center distance, and number of items, here only one slab is, so number of item will be 1. And what will be the number of bars? So to find out the number of bar, we will use one formula, that is space or span divided by spacing plus 1. So here the span of this slab for main bar is this. Okay, we will place the main bar here, and the spacing between two bars are 200 mm, and we will add 1. So that will be the span. What is the span? Span is 4000 mm, and we will divide it to 200 mm and we'll add 1. So in calculator I will go here, 4000 mm is the space divided by 200 is the spacing, and plus 1. So here 21 bar, we are using 21 bar here, so number of bars will be 21. Then we will multiply number of item to the number of bars. It will give us the total numbers. Okay, this is 21. And what will be the cut length of the bar? So we will just deduct the concrete cover from the bar, and that will be our cut length. So let's see what is the concrete cover. Here is only 25 mm, so instead this I will calculate the length of bar here. So that is 2950 mm. Okay, the length of bar is 2950 mm, so I will convert it into meters. Okay, I need it in meters, so 2950 mm, and I will divide it into 2950 divided by, because in 1 meter there is 1000 mm, so 2.95 meter is the distance of the bar. So I will go here and 2.95 I will put. Cut length 2.95, and total length will be cut length of one bar multiplied by total numbers of bars. It will give us the cut length of all bars equal to this multiplied by this. So this is 61.95. Okay, 61.95 meter total length of the bars that we are using in main. So next thing is number second is, this is the distribution bar, and after that I will insert the formula here, and that is distribution bars. Okay, and we are using the dia 10 mm here for distribution bars, and I will format this print, copy this, and here it will be 10 mm. Okay, and the spacing between the bars here is 300 mm, so I will put here 300. Next thing, in number of item, definitely it is 1, and number of bars we are using, we will use the formula space divided by spacing plus 1 that we already use in main bar. So space here, sorry, span divided by spacing plus 1. So here span is this, so we will put the distribution bar like this. Okay, in this span, so the total span is here is 3000 millimeter. So 3000 divided by spacing 300 plus 1, the formula will be this. Span is 3000 divided by, sorry, divided by spacing 300 plus 1. So we will use here the 11 bars. Okay, so total number of bars are 11 here, and the total numbers we will multiply with the number of items here, this multiply by this, so it will be what, 11. Okay, and cut length of one bar, what will be the cut length? So I will just take the distance between, check the length of this bar. I already deduct the concrete cover, so it will be 3.95. So we will divide this value to 1000 to convert it into meters, so it will be 3.95. Put here 3.95. Okay, and what will be the total length? I will drag this formula to here, so total length will be 43.45. So up till now we find out the main bars, how many numbers of main bars are using here, and the total length of the main bars and the distribution bars. So now the important point here is, we will insert the formula here. For example, this is 12 mm and this is 10 mm. So I will insert first here for 12 mm. The formula is, I will put the conditions here. So see closely here, equal to, if I will put condition if, and we will start the bracket, if C, this one is C6 equal to, what is the condition? If C6 is equal to 12, then we will take the value of this column. Okay, and I will give another condition here, and if this one not less than, not greater than to 12, that must be, this condition must be put here, because if C6 not less than, not greater than, then it will give the correct value to us. Okay, C6 not less than, not greater than to 12. So, and what I will do, I will give the comma here and then double quotes, okay, with shift double quotes, and I will put the two brackets because we use if for two times. Okay, and then we will put enter. So it is what, 61.95. Now I will put the condition here for 10 mm, so I will drag down this formula to here. Okay, now I will put the same condition for 10 mm, so equal to, if this C7 is equal to 10, then value of value of what, value of this column. Okay, and again the condition, if this one not less than, not greater than to 10, then comma double quotes two time, and then we will close this with brackets, and then this, the formula will be insert here. Okay, that is 43.45. Now what is the benefit of this formula? Here we will check again. For example, we are inserting again the another structure here, and we are calculating the main bar of that structure, for example main bars. Okay, and we are using 12 mm steel for that, and the spacing in some 200 mm, uh, for example 150 mm center center, and then number of items are 2, and number of bars, for example there are 15 bars we are using, and total numbers are, we will drag down this formula. Okay, total numbers are 30. Cut length of one bar is, for example 4 meter, and the total length is 120. So you can see that automatically this value is inserting in this column under 12 mm. So this is the benefit of this formula. So you can use this formula for any structure, like you can use for distribution bars, you can use it for 10 mm, 12 mm, 14 mm likewise. Okay, but only you have to do is only just insert the values here. Okay, insert the values here of the structure, and it will automatically put the value in under concern tables. Okay, or under concern column. So it is very useful. So again I am removing this one. Okay, delete this one, and after that what I will do, I will find the weight of this these two bars, distribution and main bars. So what I will do here, I will delete this one. Okay, and okay, delete this one. What I will do here, I will find the weight of the steel. So here what it is, for example here total length of bar, total length total length of bar. So what I will do here, just freeze this one in view, freeze main, freeze top row. Okay, freeze pane. Okay, so it is freeze now, so it will be easy to see the top column. And a total length of bar here, total length here will be, for example 10 mm total length is equal to, what we will do, equal to, we will insert the sum formula sum, and we'll drag down the whole value, and then bracket close. So total length will be 43.245, and I will drag this formula to for this one. So this is for this one. Okay, the total length of the 10 mm steel is 43.45, and the 12 mm steel is 61.95. Okay, and now total weight, total weight. So for total weight, what I will do here, I will insert the formula here. equal to, what is the formula? Equal to, we will multiply the dia for 2 times 10 multiplied by 10, okay, divided by 162.162, okay. It will give us the unit weight of the steel and will multiply the total length of the bar. So multiply by total length, okay. Okay, that is 26.79 kg. Here for this bar we need 10 mm steel, we need 26.79 kg. I will drag down this formula to here and just will modify the values. Instead of 10 I will put here 12 and here also 12. So what it is here is 55.01 kg, we need 12 mm steel. And if you want to convert it into ton, so 1000 kg for 1 ton, okay, equal to we will divide this value to 1000 because 1 ton is equal to 1000 kg, okay. So 0.026 ton and here it will be 0.055 ton. We require 12 mm and we require 0.026 ton 10 mm steel. So this is the bar bending schedule sheet and you can see that how easily calculate the things. Total weight ton, okay. What I will do here, I will go in home tab, okay, format cell, will, okay, give the color another color and another color, and you can see clearly that the total length of the bars, total weight and total weight in ton. So this is the bar bending schedule sheet and I hope you enjoy these lessons and I will see you in the next lesson. Thank you. Allah Hafiz.